It's everything okay? Now it's okay. Perfect. So it's 10:15 until 10:30, I think. I'm going to put it. Okay, so first of all, I would like to thank the organization for thinking of the Leos and to invite us to these 2 days of innovation in the railway. I think that here in these 2 days they are my musts, because before joining Celeros 1 year ago, I has been working in the Spanish Standardization Institute for almost 20 years in the railway sector. So for me, it's together the two things I most love. So go to next, please. So first of all, let's have a look on what is Hyperloop. I think it's a very mediatic for the news idea, but what is in reality and how is nowadays the development of the new way of transport. Hyperloop is based in a environment of ultra low pressure or low pressure under the atmospheric pressure, where automated vehicles are going inside a tube that maintain that low pressure environment. The guidance is made by levitation, and the propulsion is also made by levitation, by electromagnetic forces. In our case, we will see afterwards, it's only for the acceleration part, and we achieve very ultra high speeds. So the idea is to have the conventional rail, the high speed, and now we have a new system of ultra high speed. And maybe we switch the railway to guideway transport systems because it's a guided transport. The vehicle is guided, but by levitation and by and physical railways. So what are the benefits of this new way of transport? It's answering the necessities for the environment agenda for 2050. The greenhouse emissions, the CO2, the necessity of use alternative fuels, and all those things that the politicians are saying all the days, and we have incorporated in our corporate politic strategies, make that we need an efficient way of transport being all electrical. That means that there are several direct emissions during the life cycle, or not the whole life cycle, but the util life of the vehicle. The emissions to the atmosphere are zero, direct zero. The main goal is to connect city center from city center. So what has been already explained in the first presentation has too much to do with us, because intermodality is going to be a key issue in this new field. And we want to have compatible stations with compatible systems, and we don't want to invent new issues where already technologies exist. We would like to take profit of all the existing technologies. This is a step forward, but it's not something fully different. And finally, it's a weather-sealed environment in which the vehicle is carrying on. So we have to maintain the infrastructure. Of course, the cost of the infrastructure is important, but the vehicle, which is the most expensive issue in this transport mode, is going to be protected from the environment, what makes maintainability a little bit easier. So next, please. First of all, I'm talking about Hyperloop, but I'm representing Celeros, that is the Spanish Hyperloop company. We have been doing a long journey from the SpaceX, the Elon Musk competition, where our founders won the design first prize. And in 5 years, we are today as a full company with 60 persons working on this project and with really important partners, because I must say that Hyperloop is not thing of one company. Hyperloop needs of an ecosystem, because we are mainly focused in the vehicle, but we need partners for the infrastructure. For example, we are collaborating with Acciona, that is a Spanish construction and civil works company. We need to take profit of what already exists in the railway sector, in the high speed and in the maglev also. So we are collaborating also with CAF. We have a relation also for the aerodynamics and the and to work inside a low pressure environment, and we have relation with aerospace also. So we are also we have a partnership with Airbus, and for the electrification, because we are using electrical motors with Red Eléctrica, that is the Spanish main electrical company and the one that makes the national distribution of electricity. And for the materials, one of the most important materials are the steels and the magnetic steels, and we are collaborating with ArcelorMittal. So it's important to see that Hyperloop companies needs of a whole environment of different industries and technologies to work together to make Hyperloop a reality. So next, please. Where is the place for a Hyperloop in the future? The idea is to be the next step to the high-speed railway. As you know, the zero emissions necessities are making the governments to reject the short travel distance airplanes. So the idea is to take that part of the transport necessities for the passengers and to change and to shift the small distances flights into the Hyperloop. So the aviation and the airplanes would be for very long distance, transoceanic travels, and to fill that gap that will become in the near future to avoid the consumption of kerosene for short distances in flights. The distance for Hyperloop are going to be more or less between 1,000 kilometers and 2,000 kilometers for a first approach. Okay, and the speeds are going to be a cruise speed about 700 kilometers per hour to 800 kilometers per hour, and if needed, peak speeds of 1,000 kilometers per hour. So next, please. Where are we now? Hyperloop has been developed, the idea, the main concept for the last 10 years. But from 2016 to nowadays, the main developments have been, we have been working on these main developments. We have been working in the technologies inside the Hyperloop vehicle. We have been working, not only Celeros, but all the Hyperloop companies in the levitation systems, in the low pressure environments, in the parameterization of all the movements. So now this has been done, and now we are starting to introduce all of this into the first functional prototypes. So we are starting to prove or to validate the technologies inside a functional prototype, and we are at national level working in test tracks, but for a 1.3 scale, not full scale prototypes. The idea is when we have all these prototypes validated, we can start with the full scale validation. For that, we need, and we ask the European Commission to have a European Hyperloop track testing, so that we have a European Hyperloop test track for reference to all the Hyperloop companies. The idea is to start by cargo by 2027, 2028, and to deliver the first pods for passengers by 2030. This is the idea, to have the technology ready for that date. Next, please. So let's see what is going to be the Hyperloop experience. And I think that the best way is to see how it's going to be by having a virtual trip. So first of all, we have the onboarding process. We go to a station, we need all the ticketing and all the things that have been already mentioned. And we want to take profit of those common standards that need to be made, because we don't want a new transport mode with new requirements different from the rest. So this part should be in common with all the rest of transport modes. Then, next please, we go into a pressure balancing system, an airlock probably, when we reduce the pressure from the atmospheric pressure to the necessary pressure. This is one of the differences for the Celeros Hyperloop system. We don't go in vacuum or nearly vacuum pressure. We go into aviation pressure. So there is air inside the tube. That means that the certification process should be easier, because the concept is similar to the aviation, and the materials and the aerodynamics and everything is proven by aerodynamic of aviation vehicles. In the case of near vacuum, the technology, alternative technology is the spatial, and the problems with passengers and with equipment in case of any air non-tightness is going to be worse. Next, please, because I have 2 minutes. Then we have initial acceleration by a launcher of a linear motor. This is the main difference. We use the air inside the tube to be used by a turbofan, and by the rear, the exhausting by the rear of using this turbofan, we use it as a propulsion system. That means that we don't need a linear motor through all the line. We only need a linear motor for the initial acceleration, and then our propulsion is via a turbofan. Next, please. That is what I mentioned. Instead of having a vacuum inside, we use and take profit of the air inside to make it as propulsion for our system. Next, please. We use an attractive levitation system. The levitation can be in the upper part or in the lower part. We use the upper part for guidance because it has been shown to be more efficient and controllable. Nowadays, almost all the Hyperloop companies are using this attractive levitation system. Next, please. Then when we finish the travel, we go into the pressure balancing system to go again to atmospheric pressure, and then we disembark, we make the offboarding and continue our travel to the city center by other means. Next, please. So, in relation to standardization, in that case, standardization and regulation are both needed because there is no regulation in addition to no standardization. Last year, we have created the first joint technical committee at European level, Sensenelec JTC 20 for Hyperloop systems. And in the future, now we are developing the basic standards for the general architecture, terms and definitions, and general requirements for the system. But in the future, one of the most important things that we are preparing in that committee is a roadmap for standardization and inventory of existing standards. And in that case, there are almost 200 existing standards related with ISCTC 9X and also with some aerospace and aviation standards, but most of them are from 9X and related standards. So we can take profit of what you have been done during all these years in TC9X. Next, please. Sorry. That's what I mean. We are developing standardization and regulation at the same time. We need our standards help the regulation to be fixed, because in order to have by 2030 a safe Hyperloop system, we need to have regulation in place. And the idea is to use the standards as a help, as a tool for the regulator. But we need to have a regulatory environment by 5 or 6 years, the latest, so that we have 4 years to implement that legislation into our systems. And next one, please. And the next steps. First of all, we must look around what already exists. We are taking profit, for example, from a standard EN 50126 for reliability, availability, and so on. That is a basic standard for us. And we don't want to have the same problems as, for example, with IRTMS. We are starting, so we need to develop some standards from the very beginning common to all the Hyperloops and agreed with the different operators. We must establish synergies with existing technologies, for example, with communication, with signaling, with cybersecurity. That is one of the main points to be addressed in the future. And we need to collaborate with the standardization existing committees. And with all of that, we will define a roadmap not only for the JTC 20, that is for Hyperloop, but also with other technical committees that are developing the standards of the technologies, because we are not using new technologies. We are using existing technologies in a disruptive way, and we have to implement in our Hyperloop system. But the technology is already existing, and many of the standards are existing, and we need maybe to ask some technical committee to develop new standards, for example, for communication for very, very high speeds. We need a step forward for communication, for example. So that's all from my side. Last one, please. just mention that we are in the expo in Dubai. If any one of you are attending, please visit us, and thank you very much again.
Thank you very much.